So good afternoon, all of you. So let's start today's class. Now in the last class, what we have finished today? Yes, can anyone tell me? I think PS by PT formula I have given, right? Fraction, yes, no? Yes? PS by PT. Is it right? Okay. Right. So let's move ahead. Now one more note point I'm giving here. If the modulation factor if the modulation factor if the modulation factor is 1, that is 100% modulation, then the useful power is 1/3 of the total power radiated. The remaining 2/3 power is contained by carrier wave. Okay, it means what, Ram? See, this PS by PT is equal to MA square divided by 2 plus MA square. This already we have finished. This is equal to 1/3. And PC by PT, this is carried with respect to total, is equal to what? 2 divided by 2 plus MA square. This is equal to 2/3. Yesterday we have learned this, just 1/3 and 2/3 if modulation factor is 1. Clear? Okay. Okay. So this is what PC by PT, that is 2/3. And now one more note point. As modulation, because these note points are very useful when you are solving the problem. So that's why I'm giving as modulation index, as modulation index MA changes, power radiated changes. Okay, power radiated changes, and power content of carrier wave does not change with change in modulation index. Modulation index. Okay. So here you see, if this modulation index is changing, no, then power radiated will change. But whereas power content of carrier wave does not change with change in the modulation index. Okay. So let's move ahead. And now next topic, that is production of amplitude modulated wave. Okay. How to produce amplitude modulated wave? That is what we are going to learn. So first of all, let's see the basic for what we are going to use. Now, modulating signal m of t is equal to am sin omega m t. Okay, amplitude, this is angular frequency for this modulating signal. Next one, carrier signal, that is c of t is equal to AC sin omega c into t. Okay. Now this x of t is nothing but addition of these two, m of t plus c of t, and that is equal to am sin omega mt. So therefore below I am writing, therefore x of t is equal to am sin omega mt plus AC sin omega c t. This am omega am is amplitude of this modulated wave or modulating signal, omega m is angular frequency, AC similarly amplitude of carrier wave, omega c is angular frequency. C should be subscript, so always keep below and small. It is not am, a subscript m, omega subscript m, a subscript c, omega subscript c. Okay, like that. So you got this. This is what one signal we can say. Okay. Now this signal, this x of t signal is passed through square law device which produces output something like this. Y of t is equal to b of x of t plus c of x square t. Okay, means whatever the function is there, b and c are constants here. Okay, where b and c are constants. So what we did, see, we have first signal, second signal, and then addition of these two. Okay. And when we are passing this signal through one square law device, then we will get output something like that. Then we will substitute this x of t and x of t here also. We will square here and we will go ahead with derivation on next page. First of all, you note down this. Okay. Till here understood? Note down. Now let's move ahead. Now, first, I want to draw one block diagram which will give clarity how the AM wave production takes place. So I'm writing heading here, that is block diagram. Okay, then we will go ahead with derivation. Now see here, this one, first of all, modulating signal m of t is equal to am sine omega m t, this side. Okay, and from down you are having carrier signal that is equal to AC sine omega c t. Okay, so this modulating signal and this carrier signal or carrier wave, this is carrier wave, and this side what you have, modulating signal. Okay, these two we will add first, this plus symbol you can see here, and this will go through square law device. This big block you can see, this is what, square law device. This square law device will give you output y of t, and this y of t, you know what is this y of t? Y of t you know already. What is y of t? Tell me. Y of t is equal to b into x of t plus c into x square of t. This will give output here. Now this one, this box is what? Band pass filter. What is this? Band pass filtered, centered at omega c. Centered at omega c, and this side is what your electromagnetic, that is AM wave, not amplitude modulated wave, we can say. What is this? This is what? Amplitude modulated wave. So like this, production of amplitude wave will take place, and this is what I have shown with block diagram. Understood? Clear? So now you can draw this block diagram. Now let's move ahead. Now from diagram you understood what we are going to do. We are going to find the equation for amplitude modulated wave. Now see here, y of t is equal to, what is equation? B into x of t plus c into x square of t. Matlab same function we will square here. Now let's substitute x of t. Already we know what is x of t. X of t already we have. See here, am sin omega mt plus ac sin omega ct. So we are going to substitute that only here. B into, yes, am sin omega mt plus ac sin omega ct plus this c is constant, you keep it here, and now again this function we will square it. Am sin omega mt plus ac sin omega ct whole square. Clear? Now let's expand this term. Before that, this one I am writing as it is. Am sin omega mt plus ac sin omega ct plus c into bracket am square sin square omega mt plus ac square sin omega means sin square omega ct plus 2 into am ac sin omega mt into sin omega ct. Any doubt till here? Any doubt till here? Understand? Okay, right. No doubt, no. Okay, let's move ahead now. Y of t. Let me change the color from here. Y of t is equal to b into am sin omega mt plus b into ac sin omega ct plus c am square sin square omega mt plus c into ac square sin square omega ct plus 2c, or else I will do like this. First I will take this c into am into ac into 2 sin omega mt into sin omega ct. Okay, and I am underlining this part. Why? Because here I am going to substitute formula even here also and even here also. The part which I have underlined, I am going to substitute their formula. Sin square theta formula, what we have? Yes, tell me. What is the formula? 1 minus cos 2 omega mt divided by 2. I am going to substitute here. Whereas here I will substitute 1 minus cos 2 omega ct divided by 2, and here I will substitute, what I will substitute, tell me. We know formula, what is that? 2 sin A sin B. 2 sin A sin B formula. What you will get? Cos omega C minus omega M into T minus cos omega C plus omega M into T. Any doubt? Whatever I have substituted, any doubt, please ask. Understood? That is what I'm going to substitute now there. Okay. Check it once, please. Check it. Everything is correct. Yes. Okay. So let's move ahead. Now y of t. What is next step? You see now. This b am sine omega mt as it is, plus this b ac sine omega ct as it is, plus here what I am doing, this already I have substituted, no, so I am doing like this, a m square c by 2 minus what you will get, am square c cos 2 omega t divided by 2 here. Is it okay? Check it what I did. Yes, no. Yes. Clear. Okay. Next, see now this plus. Here I am writing what? AC square into C by 2 minus AC square C by 2 cos 2 omega C T. Yes, no? After this plus, this side C into AM AC cos omega C minus omega M into T minus cos, here I am keeping bracket, or else we will multiply only. 1 minute. I will write this step again. This part, okay? After this part from here. So I'm writing here plus C into AM AC cos omega C minus omega M into T minus C into AM AC cos omega C plus omega M into T. Okay. So finally, y of t, again I'm changing the color. Y of t is equal to this one as it is, BAM sine omega mt plus BAC sine omega ct plus this AM square C by 2 and AC square C by 2. So I am writing like this, C by 2 common into bracket AM square plus AC square. Okay, which part? You see here, this part and this part I have combined here. And now what is left? Here also, can I take common anything? What I can take common? Or else let it be. So I'm writing like this only, minus C AM square by 2 cos 2 omega t minus CAC square by 2 cos 2 omega CT and plus this as it is CAMAC cos omega C minus omega m into T minus CAMAC cos omega C plus omega m into T. Now whatever the frequencies we are getting, you just see omega m, omega C, 2 omega C, omega C minus omega m, and omega C plus omega m. Yes, no? Yes, omega m, 2 omega. Here you should have m, no? This one. Where? Here. This m is missing. M, 2 omega m. Okay. So whatever these frequencies which I have underlined, that is what frequencies we are getting. So out of that, which are what part is DC, what part is sinusoidal and all, that we will see on next page. Okay. Yes. Okay, where? Now is it okay? Check it once, Ray. Everything is correct. Check it once. Yes. Right. Check it once and note down now. This is finished, okay? No need to get scared. That's it. Till here only we have to derive. Okay. Note down now. Yes, everything is correct. Check it. Do it yourself. Okay. Note down. Note down then. Now see in this equation, this part is there now, which I am rounding off. This is a DC term. What is this? DC term. And now this omega m, omega C, 2 omega m, 2 omega C plus omega m, and omega C minus omega m. These frequencies are retained when we are passing it through band pass filter. Okay. So see here, this omega m, 2 omega m, 2 omega C, comma omega C minus omega m, and omega C plus omega m are sinusoids of frequency. Okay. And when signal passed through band pass filter, which rejects DC, rejects DC means this part. Okay, this one it will reject, and then what is going to retain? See here, DC term, or what we can say, and sinusoids of frequencies omega m, 2 omega m and 2 omega c are retains the frequencies omega c minus omega m and omega c plus omega m. This is what yesterday we have seen: lower band pass, lower side band, upper side band, and omega c. Yes, so these frequencies are retained. So output of band pass filter is same form of an amplitude modulated wave. Okay, so this is what production of amplitude, what you can say, modulation wave. And here one more diagram I am going to give you. How we are going to leave this into the air. This is what message signal. This is carrier. Here it is power amplifier. And this is what amplitude modulated wave we are going to transmit via transmitting antenna. Okay. Like this. So this is M of T message signal. Here it is carrier, amplitude modulator, here it is power amplifier, this is amplitude modulated wave, and transmitting antenna. So successfully we have produced what? Amplitude modulated wave and transmitted in the air through this expression. Okay, so note down this. After this, only maybe tomorrow this chapter will finish. Okay, very little part is left. Okay, so note down this. We will stop here. Okay, bye.